How to tell what MTU is being used in Windows XP. I'm suffering from a really weird problem where I randomly get the connection to the server was reset errors when trying to access web pages, HTTP error 12031 according to the Windows Network Diagnostic Tool. This happens regardless of whether the web page I'm trying to access is on the external internet or even if it's from a local Apache instance running on localhost. It affects all of the computers on our local network, Ethernet, not wireless, all of which are running Windows XP. It has been suggested to me that it might be to do with MTU used on network traffic. If I do the ping test to find out the largest packet that can go through unfragmented, I can ping the local host with a package of 1492 bytes, plus 28 bytes for a header. And I can ping our router with a package of 1462 bytes, which is 1490 bytes when you include the 28-byte header. If I try and ping something on the outside like Google, I can't get anything through bigger than 1430, which is 1458 with the header. I've tried following various sets of instructions to update the Windows XP registry with this MTU setting, updating hklm/system/current control set/services/pip/parameters/interfaces/adapterid/MTU. I've tried no end of alternative values. The most obvious correct value seems to be 1490, but I've also tried 1462, 1458, 1430, etc., etc. When I reboot the computer to make the change take effect, it seems to work for a few minutes. Hard to tell for certain since it's always random rather than consistent, but it never lasts long. Initially, when I was trying 1430 as a value, after a few minutes of working fine, the results of the ping test would decrease by 28 bytes. Suddenly I'd find that I could only get a package of 1402 bytes through to Google. If I updated them to registry setting to 1402, when I rebooted and waited a few minutes, it'd then be 1374, then 1346, etc., etc. Other computers on the network remained unaffected, still at 1430, and removing them to setting from the registry would restore things to normal, and still broken. The thing that I find the hardest about diagnosing all this is that it's very hard to tell if I'm even playing with the correct registry setting. So at its simplest, my question would be, how can I tell what MTU setting Windows is trying to use? Also, if anybody has any ideas how to tell why the MTU keeps dropping by 28, that would be useful too. For example, is there a Windows log file somewhere where it will log something at the point where the value changes? Finally, if anybody can tell me definitively how to tell what MTU setting I should be trying to use, that would be great.
For Windows 7, Windows Vista and Windows XP, the MTU for various interfaces is available from Windows itself using NETch. Windows 7, Windows Vista. To show current MTU on Windows 7 or Windows Vista, from a command prompt. And for IP4 interfaces. Note, in this example my local area connection IP6 interface has such a low MTU, 1280, because I'm using a tunnel service to get IP6 connectivity. You can also change your MTU, Windows 7, Windows Vista, from an elevated command prompt. Tested with Windows 7 Service Pack 1. Windows XP. The net syntax for Windows XP is slightly different. Note: Windows XP requires that the routing and remote access service be started before you can see details about an interface, including MTU. Windows XP does not provide a way to change the MTU setting from within Netch. For that you can follow the instructions in KB 283165, how to change the POM2 size in Windows XP. Use Dr. TCP, note, Windows 2000/XP only. Tested with Windows XP Service Pack 3. See also. Configure PIP Max Transfer Unit, MTU, size in Vista. Setting them to in Windows Vista. Change MTU settings help. KB 283165. How to change the POM2 size in Windows XP. Reports, DRTCP. Short discussion on what MTU is, where the 28 bytes is coming from. Your network card, Ethernet, has a maximum packet size of 1500 bytes. The IP portion of tcpip requires a 20-byte header, 12 bytes of flags, 4 bytes for source IP address, 4 bytes for destination IP address. This leaves less space available in the packet. Now an IP ping packet has an 8-byte header, 1 byte type, 1 byte code, 2 byte checksum, 4 byte additional data. That's where the missing 28 bytes is. It's the size of the headers required to send a ping packet. When you send a ping packet, you can specify how much extra payload data you'd like to include. In this case, if you include all 1472 bytes, then the resulting Ethernet packet will be full to the gills. Every last byte of the 1500 byte packet will be filled. If you try to send one more byte, the network will have to fragment that 1501 byte packet into multiple packets. This fragmentation will happen behind the scenes, ideally without you knowing. But you can be mean and tell the network that the packet is not allowed to be fragmented. The F flag means do not fragment. Now when you try to send a packet that doesn't fit on the network, you get the error. The packet needs to be fragmented, but the do not fragment flag was set. If anywhere along the line a packet needed to be fragmented, the network actually sends an IP packet telling you that a fragmentation happened. Your machine gets this IP packet, is told what the largest size was, and is supposed to stop sending packets too big. Unfortunately, most firewalls block these path to discovery IP packets, so your machine never realizes the packets are being fragmented, or worse, dropped because they couldn't be fragmented. That's what causes web server to not work. You can get the initial small, and LT, 1280 byte, responses, but larger packets can't get through. And the web server's firewalls are misconfigured, blocking IP packets. So the web server doesn't realize you never got the packet. Fragmentation of packets is not allowed in IP6. Everyone is required to, correctly, allow IP to discovery packets.
At Ian, I'm not so sure that Netch actually shows the currently used MTU. On my Windows XP Pro SP3 machine, I executed Netch interface IP show interface, and it reported them to value for the relevant interface as 1500. I then added the following registry keys. Microsoft says that setting enabled to discovery to 0 will set MTU to 576. Setting them to registry entry sets them to manually. I tried several values for them to entry, rebooting each time. In both cases, adding the first entry, then the second entry, Netch still reported them to as 1500. Testing with ping confirmed, or at least suggested, that the MTU value configured in the registry was actually being used though. Also, when I first tried this on my machine, the routing and remote access service was disabled, so I was unable to start it using your instructions. I enabled it by going to Control Panel and GT, Administrative Tools and GT, Computer Management and GT, Services and Applications and GT, Services. I changed startup type from disabled to manual. I then started the service from that dialog as well. I'm also not sure that KB283165 is necessarily the correct instructions for changing them to. Aren't those instructions only relevant when running the Windows PO client? If connecting to the internet through a router where the router is the PO client, as in my case, those instructions wouldn't be relevant, right? The instructions I followed, which led me to make the above changes to the registry, were in KB900926, recommended tcpip settings for WAN links with to size of less than 576, methods 2 and EMP3. Edit by Ian. Looks like you're right. Configure for 1200. But Netch reports 1500. So I guess the answer to the original question is that on Windows XP you have to use trial and error with the do not fragment flag to find the biggest packet you can send is. Then you have your MTU.
You can find MTU using ping with trial and error approach. Ping. F specifies that echo request messages are sent with the don't fragment flag and the IP header set to 1. The echo request message cannot be fragmented by routers in the path to the destination. This parameter is useful for troubleshooting path maximum transmission unit (MTU) problems. L size specifies the length, in bytes, of the data field in the echo request messages sent. The default is 32. The maximum size is 65,527. You will get packet needs to be fragmented but DF set messages when the length is too big.
See Adapter Watch. Adapter Watch displays useful information about your network adapters, IP addresses, hardware address, Win servers, DNS servers, to value, number of bytes received or sent, the current transfer speed, and more. In addition, it displays general tcpip, UDP/IP statistics for your local computer.
If you want to support the channel, please consider subscribing.